Hi, I'm Sophie Germain. You probably don't know who I am, but I'm excited to tell you. This is my story. I was born on April 1st, 1776 in Paris, France, in the wake of the American Revolution. My father worked at the Bank of France, so growing up I spent most of my free time in his library reading.
By the time my daughter Sophie had turned 13, the French Revolution had struck France. Due to the revolts taking place in Paris, we kept Sophie in the house at all times. She wasn't happy about it, but we knew we were doing the best possible thing for our daughter.
While confined in my house, I read constantly. The most pivotal thing I ever read was about the legend of Archimedes' death. As legend has it, Archimedes, a famous mathematician, was stabbed by a soldier after refusing to meet their demands. He was too engrossed in a math problem to think about anything else. I thought that math must be pretty cool if someone was that focused on it. This really got me interested in mathematics, and I started studying it using my father's books. My parents did not approve.
I know Sophie was frustrated by our attempts to stop her from continuing her studies. We were just doing what was best for her. Since we were of the middle class and not upper class, math wasn't an appropriate interest for Sophie. She needed to focus on learning how to become a good mother and wife. However, eventually when she started to study at night using just the light of her candles, we realized there was nothing we could do, and we decided to let her pursue her passion.
I was overjoyed when my parents told me I could pursue my studies. I started to teach myself more complex math topics, such as calculus. Then when I was 18 in 1794, Napoleon founded the École Polytechnique Academy for Science and Math. When I found out, I instantly wanted to apply. It seemed like the perfect fit. The only problem was the school only accepted men.
It wasn't a question of intelligence. It's simple genetics. Women just couldn't keep up with us. It wouldn't be fair to them. Really, we were doing them a favor by not letting them join the academy.
I was not put off by this. Under the pseudonym of one of the academy's previous students, M. LeBlanc, I managed to get the notes of several different mathematics courses and use them to study and further my knowledge. Soon, one mathematician started to stand out to me. J. L. Lagrange was a professor at the academy who made many incredible strides in mathematics. I finally decided to use the pseudonym to write and turn in a paper to Lagrange to see what he thought. I felt guilty about concealing my identity, but I was scared that if he realized I was a female and not actually enrolled in the academy, he would look down on me and not read my paper.
I was extremely impressed with the paper. After reading it, I decided I want to meet M. LeBlanc. Imagine my surprise when I found out M. LeBlanc was a woman. It all the more proved how talented she was, that she could write so well without the opportunities that a man would have. I took her on as a mentor and introduced her to many famous mathematicians and scientists.
Later on, I started work in number theory. The work of Carl Friedrich Gauss, a German mathematician who worked with geometry and prime numbers, really intrigued me. I wrote to him and shared some of my work. I used my pseudonym again, just in case he would look down on me for my gender.
Like so many before me, I was extremely impressed with Sophie Germain, or who I thought at the time was M. LeBlanc. We exchanged letters for years, and it wasn't until 1807 when I discovered her true identity. After the French occupation of Hanover, she was worried about my safety and asked a family friend in the French army to check on me. Naturally, after that, I discovered her true identity, but that didn't stop me from being amazed with her intelligence and continuing our correspondence. Unfortunately, a year later, we stopped our correspondence due to my new job teaching astronomy.
Despite the end of my correspondence with Gauss, I continued my work and developed a theorem that made great progress in proving Fermat's last theorem. Fermat was a mathematician in the 1600s.
My expression stated that x to the power of n plus y to the power of n equals z to the power of n had no positive integer solutions for x, y, z when n is greater than 2. Basically, I said that it is impossible for a cube to be a sum of two cubes, a fourth power to be a sum of two fourths power, or in general for any number that is a power greater than the second to be the sum of two like powers. I intended to document a proof of this theorem.
Sadly, Fermat died before completing the task of creating a proof. Throughout my studies with Gauss, the theorem fascinated me endlessly. Since Fermat had written his works and proofs in the margins of books and his son published his notes, even hundreds of years after his death, mathematicians were trying to prove his theorem. I was determined to be the mathematician who would finally do it. My work led me to split up Fermat's last theorem. In one of my earliest letters to Gauss, I compiled a list of prime numbers, or p, that was plugged into 2p plus 1, and would produce another prime number. An example of p would be 5 because 2 times 5 plus 1 equals 11, another prime number. For values of n equal to these special primes, there were probably no solutions to the equation x to the power of n plus y to the power of n equals z to the power of n. By probably, I mean that there would be only one possible scenario in which there was a solution. The solution would only be if x, y, or z was a multiple of n.
Sophie used her work to prove that Fermat's theorem worked for integers all the way up to 197. She submitted all of her progressions to me with the hope that I would advise her in her efforts to prove this theorem. Unfortunately, she was unable to prove the general theory. However, under my guidance, she was able to create framework that would greatly help mathematicians in the future who also attempted to prove this theorem.
After working with Fermat's last theorem, the work of Ernst Chladni became my newest interest. Chladni was a German scientist known for his research in calculating the speed of various gases as well as with vibrating plates. I eventually came across a contest at the Paris Academy of Sciences that asked contestants to use Chladni's research to conduct additional experiments and then present a mathematical equation for the vibration of an elastic surface. This inspired me, and I was looking for a new project. I began my work. There was a 2-year deadline, which I met in 1811, submitting an anonymous paper.
The Paris Academy of Sciences Ernst Chladni Award goes to... no one! Unfortunately, our only contestant was Sophie Germain, who we cannot give the award to, due to her clear lack of formal education. Better luck next time!
And I did have slightly better luck next time, and even better luck the next. I turned to my original mentor, J.L. Lagrange, to help me correct my previous errors and resubmitted my paper 2 years later. I only received an honorable mention. In 1816, I again submitted the paper, but instead I wrote a memoir about the vibrations made by elastic plates. Finally,
the Paris Academy of Sciences Ernst Chladni Award goes to... Sophie Germain!
My win helped me get introduced to many prominent mathematicians. However, despite having won an award from the Paris Academy of Sciences, I was still not permitted to attend the Academy's sessions in mathematics because they excluded any women who were not wives of members. In my opinion, this was ridiculous, but there wasn't much I could do. 7 years later, I was finally able to obtain tickets to the sessions through becoming friends with Joseph Forer, a secretary of the Academy who gave me tickets. This made me the very first woman to come to the sessions who wasn't the wife of a member. Later on, I attended sessions at the Institut de France, where I continued to impress. Then in 1820, I collaborated with a well-known mathematician on the refining of my proofs and my previous work in number theory. I continued my work in elasticity and wrote several more memoirs on the topic, which were published.
In 1829, Germain encountered her first unbeatable obstacle. She was diagnosed with breast cancer. However, she was not deterred. She continued to work in number theory and published many more related papers. Sophie Germain died 2 years after her diagnosis on June 27, 1831, at the age of 55. Germain's work continued to live on in mathematical and scientific fields, and her legacy as a strong and smart woman who braved obstacles and boundaries.
Not only did Sophie Germain make huge advancements in proving Fermat's last theorem and in the fields of elasticity and acoustics, she showed the world everything one can accomplish despite being disadvantaged. While the world weighed her down with stereotypes and bias around her gender, she used her intelligence and work ethic to make huge strides in the world of mathematics. Sophie Germain's gender made her life much harder, to the point where she had to use a male pseudonym to be noticed.
Gender stereotypes still greatly affect millions of women today, and likely they will not disappear soon. However, if people like Sophie Germain persevere and work hard enough to show the rest of the world their incredible qualities despite their gender, perhaps women in future generations will begin to not have to struggle so much to get to the top.